Two-dimension graph is the topic. We will deal with a lot of plane. Plane is two-dimension shape without any thickness. And then we talk about curve. In mathematics, curve can be about any curve or straight line segment. Straight line segment have two endpoints, right? So the first one is the simple curve. So for simple curve, the definition is you can trace in such a way that never touch a point more than once. So I'm going to give you some example that's yes, a simple curve, not a simple curve. The simple curve can be something you can trace and touch each point just one time. So I can have something like this. So I'm going to not overlapping each point more than one time, right? Or I can start here and make a rectangular shape. Or something like that. This all can be considered a simple curve because I don't trace this graph and touch any point more than one time. But if I have a shape like that, then I'm going to trace this particular point more than one time, right? This is overlapping here, so that's not a simple curve. Or if I have something like that, there's no way for me to trace this graph and don't touch the same point more than one time. So those will not be simple curve. Is it okay? The second one is closed curve. Closed curve means you can trace the figure in such a way that strict starting points and ending points are the same. So again, I'm going to give you some yes and no example. If I pick up the graph from the top here, which one would be a closed curve? The starting point and end point would be the same. It doesn't need to be simple curve, but the starting and end point should be the same. The 8, okay? The 8 is correct. I can start here and end here at the same point, right? Can you give me one more? The E can be, so I can start here, try to do an E and end at the same point like here. Can this rectangular shape be 1? Start and end point the same? Yes, and close, right? All right. How about the Z? Nope. Start and end point not the same. How about this guy? No? Okay. Start and end point not the same, right? Or if I have something like that, start and end point not the same. Are we okay? All right, the next one is simple closed curve. So they're going to combine the two together, right? So you have to trace it without overlapping any points, and the beginning and the end point need to be the same. Do we have any? The E can. The start and end point the same, and they're not going to be repeat. One more. The rectangular one, okay. So I'm going to give you one extra one, maybe something like that. Okay. One that is not a simple closed curve. Can the egg be simple closed? No. Because even if it's a closed curve, you start and end at the same point, but they also overlap, right? Or I'll give you one more, something like this. It's Okay, question for that. Now, we kind of talked about that earlier. A plane is going to be a two-dimensional graph that has no thickness, just two-dimensional. So any regular geometry shape that we have learned so far could be a two-dimensional shape, like a rectangle, like a square, like a circle, triangle, trapezoid, parallelogram. So a lot of those would be considered as two-dimensional plane shapes that have no thickness, right? They're two-dimensional but no thickness. I think I'm missing one student today. Yep, just Maddie. All right, are we ready? So the next one would be polygon. What is polygons? It's going to be a simple closed curve composed only of line segments. So earlier we count the curve with straight line segments and curve both. But when we are working with polygons, they are simple closed curve, but we only work with straight line segments. So we can categorize it as 3, 4, 5, 6, 7, 8, 9, and whichever number side. So if it's like a three-sided shape, what do we call those? A triangle. And you can, draw a few triangle if you like. Four-sided shape as the family. Start with a Q. Quadrilateral. How do you spell it? Q, U, A, D, R, I, L, A, T, E, R, A, L. Okay. All right. So it could be a square, it could be rectangle, or other four-sided shape. Yeah, trapezoid. Trapezoid is a four-shaped line. Yes. Okay. There's a bunch of them. As long as they're four-sided, that's fine. Five-sided, what do we call those? Pentagon, how do you spell it? Thank you. So I need a five-sided shape. I'm going to just draw one, okay. Six-sided. Hexagon. How do you spell hexagon? Thank you. So it's going to be a six-sided shape. I think it's going to be like 1, 2, 3, 4, 5, 6, something like that. Seven-sided. That's not as popular. The up would be A. Start with H. Heptagon. Good job. You don't hear that a lot. Okay, somehow seven side. I did it yesterday. I didn't want to put it wrong here. Something like that. So as long as it's seven side, it's going to be okay. Eight-sided. Octagon. How do you spell it? O-C-T-A-G-O-N. Okay, so they all end with AGON, right? N-gon just means they have, I don't know how many sides, but I should draw octagon for you. 1, 2, 3, 4, 5, 6, 7, 8, something like that. I know it's not very clear, but as long as it's 8-sided, okay, like this, and then straight line, down again, close. All right, so those are the basic. These same figures are congruent, so which we use a symbol like this. Congruent mean they are exactly the same, all the line segments are the same, and then all the angles are the same. It's going to be congruent, exactly the same. So if they're just similar, they don't have the equal here, okay? So what do they mean IFF? I didn't misspell it. This means if and only if they have the same shapes and size. So all the sides need to be the same and all the angle need to be the same. So we are saying each corresponding pair of angles are congruent and each corresponding pair of sides are the same length. Okay, so the angles are the same and the side, each corresponding sides are also the same to make them congruent. And this is the symbol for congruence. Okay, and last time we talked about the different triangles. Some of them we saw them by sides. Some of them we saw them with the same kind of angles. Which, by the way, we also gave you this handout, right? So it told you what the symbol for equal to, not equal to, approximately, is greater than, less than, greater than equal to, less than equal to, and the angle sign. This is perpendicular, parallel, this is similar, this is congruent, not congruent, plus and minus, and line segments, line, and this is measuring the length. So these have different symbols here. When you get a chance, like take a quick look. Make sure you understand them. This is for your information. All right, last time we talked about triangle with all same sides called what? Equilateral. They have the same line segment. They have the same angles, right? And because they have 3 angles and add up to 180, if they are equilateral, they are 60 degrees each, right? How about isosceles? 2 sides are the same and the base angle are the same. So those would be isosceles. And then we have scalene, meaning they would be on the test. Okay. 3 different sides for the triangle, and as you can see, we have one quiz today about those, but next Monday we're gonna have another geometry one with this information, so you need to start studying, okay? And then we have different angle type of triangle. Right triangle have one right angle, right? A cube angle has all 3 angles are acute. Obtuse, just one angle is more than 90 degrees. So last time we say the triangle should add up to 360 degrees. Okay, that's my triangle. So I cut out triangle here. It has angle 1 and 2 and 3, right? So I have the same one, look messier here, but they are the exact same triangle, right? So we want to prove that the 3 angles should add up to 180 degrees. So I'm going to cut out my angle 1. I'm going to cut out my angle 2. And I'm going to cut out my angle 3. So these 3 together should form a straight line, right? Kind of confused. How should I do it? Maybe that. What am I doing? They should add up to 3. Angle should add up a straight line angle, maybe like that. Okay, that's why they're 180. So all 3 of them would be supplementary, not like, I don't know if I can call it supplementary. Supplementary would be like 2 angles, so, but the 3 angle would add up to 180 degrees. So this is how you prove like the inner angle of triangle would add up to 180 degrees, okay? All right, so that would be a good activity for elementary school student to do. Okay, to summarize it here, if you look at a right triangle, I'm going to draw one here. It should have a right angle. So we can have a right angle along with what? The other 2 should be obtuse of a cube, a cube angle. All right. And how about an obtuse triangle should look kind of like that? Then you should have how many acute angles? 2 acute angles and 1 obtuse angle. Okay. How about an acute triangle? How many acute angles? All 3 angles should be acute, right? Does it make sense? So if you were not here last time, make sure you watch the video and have the notes and study the notes, and make sure if you don't have homework 11 today, I definitely need it by Wednesday, otherwise it's going to be 0, okay? And I don't want anybody to have 0 homework because it's going to hurt you. We have a total of 12 homework, so this would be the last 2 homework. Okay, question for this? The next part would be the quadrilateral. We didn't do the quadrilateral last time, right? Okay. So the 2 major type of planes or 2-dimensional figures you need to have good knowledge about would be the triangle and the quadrilateral. Okay, so let's look at the quadrilateral. And quadrilateral obviously mean they are 4-sided shapes, and the definitions for trapezoid. So trapezoid is one type of quadrilateral, right? What makes something a trapezoid? They are 4-sided shapes with at least 1 pair of parallel sides, okay? So I can have a parallel side like this here. I can have one like that. They are trapezoids. Or one like that. They are all trapezoids, okay? 4-sided shape, 1 pair of, at least 1 pair of parallel line. Parallelogram, they need to have 2 pair opposite sides of parallel line, but they are also 4-sided shape, right? So we can have something like that. So this pair are parallel to each other, and this pair are parallel to each other. I'm just going to draw a few random ones. That's not very straight, sorry about that. I make this more like a square, but a square is also a parallelogram. Okay. Okay, how about a kite? Kite look like a kite, which means it's a four-sided shape, a quadrilateral with two pair of adjacent line. They are congruent. What is adjacent? What does adjacent mean? Just a word. What's the definition of adjacent? We talked about it on the last test. When they have adjacent angle and they make like supplementary angle.
Oh, they're next to each other.
They're next to each other. It's just an English word, it's not math. Okay, so the two sides next to each other are equal to each other like that. So they form a kite. So this pair and this pair. Or you can have something like that. I don't know. As long as these two adjacent sides are the same, these two adjacent sides are the same. Rhombus also a four-sided shape quadrilateral, but this one, all four sides need to be the same. So I'm gonna do the best I can to make a rhombus. 1, 2, 3, 4, they all are the same. That's why sometimes like you can see the rhombus could be a parallelogram too, if all the sides are the same, but the two are going to be parallel. Rectangle, we are familiar with that. It's quadrilateral with what kind of condition? All the angle need to be 90 degrees. Because all the angle are 90 degrees, it will make like these two parallel to these two parallel, and also these two sides and these two sides are the same because of the right angle. So it could be like that. But as long as it's like a four-sided shape and four right angle, we'll make them rectangle. So on the test and your homework, I may say I'm a quadrilateral with all angle congruent that describe which one perfectly, which would be the rectangle one, okay? I mean, it's also covered the square, but particularly this more for the rectangle. All right, the last one would be square. So what makes something square? It's a quadrilateral with? Yes, if just four sides congruent, that could be a rhombus, but if in addition to that, all four angles are 90 degrees, that would make them a square, right? I call this 1, 2, 3, 4. I cannot call this ABCD angle, okay? Because the angle A could be the outside part also. So I'm going to say the line segment AB will equal to the line segment BC, equal to the line segment CD, equal to the line segment DC, and angle 1 will equal to angle 2, will equal to angle 3, will equal to angle 4, equal to 90 degrees. Are we okay with that? So you know the sum of the inner angle of triangle is what? If you add up the inside angle of a triangle, it will equal to 180. How about for a quadrilateral? Why is it 360? It's correct, but can you prove it to me it's going to be 360? Okay, so if it's a square, 90 times 4 is 360, but if something like that, can we tell this is going to be 360? Huh? Yeah. So do you believe this is for triangle is going to be 180 first of all? Because we show you, right? We cut up a triangle and they actually can form like a 180, right? So do you accept these facts first of all? Okay, so we're going to use triangle to prove that. So angle quadrilateral, we're going to say the sum of the four inner angles for a quadrilateral is going to be 360 degree, and we are going to use a random quadrilateral. Any quadrilateral will work. I'm going to call this ABCD, and we're going to put a diagonal line segment here. So I'm going to say the diagonal is going to be AD here. What they mean diagonal line is a line segment that joins two non-adjacent vertices. So I cannot connect A and B, right, or A and C, but they are not connected adjacent points. So we're looking at here. I am using the same shape. I'm going to do the best I can to cut it about the same. So this is A, B, C, D, and I can put a bunch of angle in here. I can say this is angle 1, 2, and 3. Angle 1, 2, and 3 should add up to what? 180. I'm looking at triangle ABD, right? Angle 1 plus angle 2 plus angle 3 equal to 180 degree because they're within the triangle, right? Do you agree? Okay, and then I'm going to have a few more. I'm going to have 4, 5, and 6. 4, 5, and 6 should add up to 180 also, right? This is for triangle ACD. We will add up angle 4 plus angle 5 plus angle 6 also equal to 180. So if I just add up all of them, that should be the inner angle of the quadrilateral, right? So this is one angle, this is one, this is one, this is one. So I add for the quadrilateral ABCD, we will add up angle 1, 2, 3, 4, 5, and 6. All together should be 180 degree plus 180 degree, right? So that should be 360 degree. So for any quadrilateral shapes, you can cut them into two triangles, and that's why those angles should add up to 360 degree. Are we okay with that? Questions? Okay. So that would be the first page of your homework 12. It's all the triangle and quadrilateral stuff. And then on the next page, it has some question, ask you to calculate area. I didn't put any parameter question there, but we also need to find some of the sign for the line. So one of the handout I gave you last time have the formula finding the area and parameter of square, rectangle, triangle, circle, sphere, cube, rectangular solids, wide circular cylinder. So that's for your information. If any of the question on the test asks you to find area or parameter, formula would be given to you. But you need to kind of look through this because we assume you have some idea how to find area and parameter, okay? Area is like in here, parameter will be the outside part, right? So we're going to give you some example to follow so you can do your homework questions that ask you to find area of the random shapes. So the new handout you get today, on the very back, it has some thing that asks you to find the compound area, right? So if you look at the first shape, it look like you can cut that out as a rectangle here. And then outside here has an extra triangle, right? So this is the handout from today that you should have picked up, and it's a transformation, right? So just on the very last page, because you have homework questions like this, so I want to talk about this first. So when you have compound area like that, you may need to cut them into here. So you're trying to find the area of this rectangle plus the area of this triangle. So can you go ahead and try that for me, please? How do you find the area of the 5" by 4". So on your homework, you can say you are trying to find the area of the rectangle 5 by 4, adding the rectangle, with the triangle, which is 2 inches and 3 inches here. What is the formula to find the rectangular area? You will multiply the length times the width, okay? And this one, the triangle would be, it's on the formula sheet, what is it? 1/2 times the base times the height. Okay, what is the length times width here? Which one you call the length? It doesn't really matter. 5 times 4, and then the other one would be 1/2. The base is 3. The height is 2. Okay, so the first number would be 5 times 4 is 20 plus, yeah, you can cancel the 2, right? So plus 3, together we have 23. This is area. What unit is this? Inch square. Are we okay? So something like that. And the second one, they want you to find the shaded area. So the shaded area, you're going to need to use the big one, subtract the little one, right? So on the homework, you can, draw this and then tell me how do you find the big area? 3 times 3, subtracting 2 times 2, 3 times 3 is 9, minus 4, together we have 5 centimeter square. Are we okay? So on the homework, I will expect you will draw this part, okay? Draw me the shapes, show me the step, have the correct units. Can we do something like that? All right, the other thing on the homework is finding a missing side from a right triangle. What do you know about that? If you have a right triangle, if you know one side and one side, how do I find the missing side? Using something called good Pythagorean theorem. How does that work? on the TSI last week. A squared plus B squared equal to C squared. So let's do two examples because I don't know which one you will get from your homework or the test. So they say found the missing side. So one of them I have 3, 4, and I don't know this guy. I don't want to say C because it will give it away. And then the second one I have, cannot read my handwriting. And I don't want to look the same way. Let's do it like that. I have 6 and this is 10 and I don't know this one. Okay. So we need to be able to identify if the missing one is A, B, or C. And how do I tell?
Your longest side is the
Yes. So you can see where is the right angle. Usually like facing the right angle is your hypotenuse, is the longest side, like you say, that would be the C, right? And so this one, I know A, I know C, but I don't know B, something like that. So again, this is going to be A squared plus B squared equal to C squared, right? So when I set that up, then what number do I have in there? A can be, B can be, okay, I'm just going to go order, okay, because the AB doesn't matter. And then I don't know C, right? So what is 3 squared? Plus 16 equal to C squared. 9 plus 16 is 25 equal to C squared. To solve for C, I need to take square root both sides. Normally, the other side come with plus and minus because square and square root will cancel each other, right? What is square root of 25? C equal to plus minus 5, but this is length, right? So it has to be positive, so C equal to just 5. Are we okay? Question for the first one. Okay, the second one, the missing one is what? Yes. But is it A, B, or C? It could be A, it could be B, but how can I know this is not C? The 90 angle is here, facing this one, so this one would be C, right? And this is the longest line of the right triangle, so that would be my C. So C is going to be 10 squared. You can plug the 6 in A or B, doesn't matter, but we don't know B, right? If I plug it on A. Okay, now what? 30, sorry. I'm worried about time for the quiz, so 6 squared is going to be 36 plus the B squared equal to 10 squared is 100. And then we need to solve for B. So first we will subtract 36 both sides. 100 subtract 36 is 64. And then we need to take square root both sides. The right side is supposed to come with plus and minus. B will equal to plus minus 8, which because it's length, so it's just equal to 8. Are we okay? Questions? If it comes with units, you need to put the units for your answer, okay? There is one more type of question on your homework that I want to talk about briefly. that seems to be a challenging question for students, is converting units. So you have two handouts that talk about different units and their conversions. The one from last time, it has the formula to convert temperature, and then it also talk about different units, and the one from the United States is kind of difficult because it's not metric, so they're not doing 10 to some power. It has random number that you actually have to remember. So if I ask you to do something like that on the test, I'm going to give you the number, some of them, so you can use it to help with your questions. So using those information from the handout, like this one, so have that next to you, please. We are going to try some example. So one of them I want you to try is converting temperatures. Um, The first question is starting with 15 degrees Celsius to Fahrenheit. The second question we're going to try is starting from 38 degree Fahrenheit to Celsius. Which formula should I use for the first one? Looking at your yellow handout with these two formula, which one should I use? The one started with F or C? Which one? Your answer need to be in F Fahrenheit, right? So I should have, that seems to be the main question. Which formula should I use if my answer need to be Fahrenheit? The one with start with C or F? F equal to something, right? So F equal to 9/5 C plus 32 degree. So F equal to 9/5 times what? The given 15 degree here. Okay, how do I multiply fractions? This is similar to 15/1. And top multiplied by top, bottom multiplied by bottom, or you can cancel, right? Top with bottom. So anything I can reduce? Okay, I'm going to write it one more time. You should know how to do it because we spend so much time with fractions. So you can top times top, bottom times bottom, and reduce, or you can reduce anything on top with anything at the bottom. So what can I reduce? 5 times 1, 5 times 3. So F equal to 9 times 3 is 27 degree plus 32 degree is 59 degree. I want you to write your answer like this. 15 degrees Celsius equal to 59 degree Fahrenheit. Are we okay? For the one converting to Celsius, I should start with what? C equal to, so the formula says C equal to 5/9, plug in parenthesis, be careful, F minus 32 degrees. So it's not quite the same, right? So C equal to 5/9, parenthesis, we plug in what? 38. So this need to follow the order of operations, right? To follow the order of operation, we do what first? The parenthesis first. So C equal to 5/9. 38 subtract 32 will give me 6. Can I write 6 over 1? Is it okay? Okay. Anything we can reduce? 9 with 6 by 3. Okay, 3 times 3 and 3 times 2. So at the bottom we have 3. At the bottom, on the top, we have 10 divided by 3 is about 3 times what goes to 10? Yes, 3.3 repeating degrees Celsius. So I'm going to say the answer is going to be 38 degrees Fahrenheit equal to 3.3 degrees Celsius. Are we okay? Okay, I need to show you at least 2 more so you can do your homework. So one of them is converting how many feet to how many meters? "20 feet to meter." So using your handout, I need to find out things that related to feet and somehow link it to meters. So I know 1 feet can equal to what? Look at your handout. 1 feet can equal to 12 inches. Okay, thank you. And 1 inch can equal to something linked to the metric system. It's on your handouts. It's boxed in and very obvious. 1 inch equal to 2.54 centimeter. Okay, and then how are we going to link it to meter? 1 centimeter or some centimeter with 1 meter? 1 meter equal to 100 centimeters. So we're going to need to use them to convert, okay? So we found them somehow linked together from feet to meter. Is it okay? It's from this handout. So you need this handout to do your homework. All right, so we started with 20 feet, right? And then somehow we need to end with 1 meter here. So from feet to meter, basically. So this number don't have a denominator, right? I put the 1 here. Is it okay? And then I'm going to multiply this 2. I need to get rid of feet, so I know 1 feet is going to be how many inches? 12 inches. I put it like that because I want to cancel it, top and bottom. Are we okay? And then for the feet, I need to get rid of feet, right? Which I did. And then I need to get rid of inches. And I know I need to put the inches where? Top or bottom? Bottom for inches. So 1 inch equal to centimeter. And then at the end, I want to get rid of centimeter because I want to leave it as meter, right? So 1 meter is 100 centimeter. Okay. So it's kind of like 1 by 1 because they're the same thing, right? So it's like I'm multiplying by 1. But this is what happens. So when you see that, first write down what are all the things that we need. And then I need to get rid of feet. So if we go to the bottom, I need to get rid of the inches. So inches get to the bottom. I need to get rid of the centimeter. Centimeter get into the bottom, like that. Okay? And then we can start canceling, right? So I'm going to cancel the feet. I'm going to cancel the inches. I'm going to cancel the centimeter. So it will end up with meter, right? And then multiply all of them together. So we have On top is 20 multiplied to 12 multiplied to 2.54 multiplied to 1, right? At the bottom is just 1 times 1 times 1 times 100, right? And then this will end up with meter. Okay, gonna need a calculator. Anybody have a calculator next to you? I know at the bottom is 100. Twenty times 12 times 2.54, 609.6 divided by 100 will be, give me all the decimal places. Meter, right? Okay. So the answer will say that 20 feet will be the same as 6.096 meter. Do you kind of see how that works? Okay, write down the conversion, multiply, make sure you cancel out, just leave you with meters. One last question. You guys, some of you come in a little bit late, so I have to do it. And you have homework questions like this, you have exam questions like this, okay? So the last one would be feet per second to miles per hour. So I need to know miles will equal to some feet. And then somehow the second can convert to hours. 1 mile equal to how many feet? Anybody memorize it? I don't. Okay, and then somehow the second need to turn into hours. So second can turn into what first? Minutes. 60 seconds is 1 minute. And then from minutes, I need to turn into hours, right? So 60 minutes equal to 1 hour. Thank you. So the question started with 100 feet per 1 second, right? That's the weight, right? Remember we have the special kind of ratio. It's the unit per unit. The last unit is a single unit. Times, okay, so I need to cancel the feet. So I'm going to put feet at the bottom and put miles on top. So what do I put on top for number? 1 miles equal to 5,280 feet. And then I need to get rid of the what? No, I need to keep the miles. It's in the answer. I need to get rid of second. So second go to the top or bottom? Top to cancel it, right? How many seconds? 60 seconds is 1 minute. But do I need minutes? No. So I need to get rid of minutes. So minute go where? Top. 1 minute need to convert to hours. So how many minutes? 60 minutes is 1 hour. So we're going to cancel the things that we don't need. I cancel second. What else to cancel? Feet. I need to keep my miles, right? The minute need to go. I need to keep hours, right? So on top now we have 100 times 1 times 60 times 60, right? And this is miles. And then at the bottom we have 1 times 5,280 times 1 times 1, and I leave with hour, right? Okay, do you have some idea what this is, what's going on here? Okay, so now we have to multiply and divide. So on top we have 100 times 60 times 60, which will give me 36, how many zeros? 4 zeros. At the bottom is just 5280, right? This is miles per hour. Okay, this number divided by 5280 is going to give me 68 point. Apparently this is repeating, right? This is in the term of miles per each hour. So the final answer will be 100 feet per second is going to be the same as 68.18 repeating miles per hour. Are we okay?